Chapter 14, Data and Information Governance. Data governance, or DG, is the overall management of the availability, usability, integrity, and security of the data employed in an organization or enterprise. It is a specific enterprise information management, or EIM, function that supports coordination among all other EIM functions. Information governance, or IG, is an organization-wide framework for managing information throughout its life cycle and for supporting the organization's strategy, operations, regulatory, legal, risk, and environmental requirements. Data and information governance programs rely on quality data and information for the following reasons. 1. To make informed decisions. 2. To evaluate patient care and population health. 3. To evaluate business processes. 4. To evaluate financial stability. 5. To reduce security breaches. And 6. To control e-discovery costs. Effectiveness is the degree to which stated outcomes are attained, while efficiency is how the desired outcome is achieved or produced, particularly without wasting resources such as time, personnel, and money. Data governance is a subset of information governance, as data is the foundation upon which information is built. The acronym GIGO, or garbage in, garbage out, is an appropriate metaphor for the importance of effective data governance, as garbage data provides garbage information. This garbage or inaccurate information leads to poor decisions. E-discovery, for example, pre-trial activities wherein participants acquire and analyze any electronic data that could be used in civil or criminal legal proceedings. Data governance and information governance are examples of the little picture, big picture concept. The smaller aspects of data governance provide the little picture while supporting the big picture of information governance. Information governance is the big picture, the all-encompassing information management of the entire healthcare facility. Data governance is in many ways the foundation for HIM because it includes data modeling, which is the process of determining the user's information needs and identifying relationships among the data. Data mapping, which allows for connections between two systems. This connection allows for data initially captured for one purpose to be translated and used for another purpose. Data audit, which is an organizational procedure for monitoring the quality of data by analyzing reports for anomalies, inaccuracies, and missing data. Also, data quality controls, which are tools such as edits and field types used in information systems that help ensure data quality. Data quality management, which is the business processes that ensure the integrity of an organization's data during collection, application, including aggregation, warehousing, and analysis. Data architecture, which is the development and maintenance of specifications about data that reside in electronic databases. And finally, the data dictionary, which is a descriptive list of the names, definitions, and attributes of data elements to be collected in an information system or database whose purpose is to standardize definitions and ensure consistent use. Data governance has a significant impact on healthcare and HIM. A healthcare facility benefits from a strong data governance program in many ways, including improved data quality, reduction of duplication, improved trust in data, efficiencies, cost savings, and risk mitigations. Metadata is often referred to as data about data, but this definition oversimplifies the concept. A better definition is structured information used to increase the effective use of data. It includes the electronic timestamp of when data was created, accessed, or manipulated. Metadata identifies when an entry was created and who created it, from where it was accessed, and all changes made to the file or document. During an information breach investigation, a single employee's electronic activity or the activity that occurred at a single workstation or terminal can be evaluated. There are three types of metadata: descriptive, structural, and administrative. Descriptive metadata addresses specific data elements acquired and used by the information system. The data dictionary established for all the data sets within the information system is an example of descriptive metadata. Structural metadata is the process of acquiring, storing, manipulating, and displaying data. Data models, such as entity relationship diagrams, or ERD, and data flow diagrams, or DFD, are diagrammatical or graphic tools used to help program the system and to identify the areas of inefficiency. Administrative metadata is programmed in the information system in order to generate data about the usage of the information system, such as audit trail and activity reports. The audit trail identifies tasks such as who accessed the information system or when and where someone performed a certain data function. Data mapping supports connections between two systems. This connection allows the data initially captured for one purpose to be translated and used for another purpose. When mapping data, there is a source and a target. The source is the original data set that is being mapped from. The target is the data set that the source is being mapped to. Information is a valued strategic asset and should be managed just like people, processes, money, and other resources. An asset is any resource that is useful and provides a valuable quality. The value comes from its relative worth or importance. Information is a valued strategic asset because of its role in planning for the future of the healthcare facility, making sound clinical and administrative decisions, and managing the financial resources. Much like a silo on a farm where each silo holds a different type of grain, a data silo is a separate database or system within a department that does not integrate into the main organizational system, nor can others outside of that specific department access it. Information governance addresses these issues by managing information overall, not just data of one type or in one location. The information can then be used to meet the needs of the healthcare facility. Business intelligence is the end product or goal of information governance. Business intelligence includes information technology and procedures to analyze all aspects of the healthcare facility's performance, including patient care and healthcare services delivery, personnel, clinical applications and outcomes, and all administrative functions. In healthcare, big data means electronic health data sets so large and complex that they are difficult or impossible to manage with traditional software and or hardware. nor can they be easily managed with traditional or common data management tools and methods. Because staff throughout the healthcare facility should be involved in the information governance processes, the healthcare facility should create an information governance steering committee. This committee could be created and dedicated to information governance, or the role could be assumed by an existing committee. The Information Governance Steering Committee is responsible for the oversight of the information governance program and has many roles. The roles of the Information Governance Committee include identifying the responsible individual or department responsible for information governance functions, developing relationships between individuals and departments responsible for information governance functions, creating an information governance policy, and coordinating information governance efforts. The Information Governance Steering Committee is part of the leadership structure of the healthcare facility's information governance efforts. Information governance must have permanent leadership structure, resources, including human, monetary, and equipment, and executive level commitment. Executive level personnel can be referred to as the C suite, a jargon term that refers to the positions with titles beginning with C, such as Chief Executive Officer or CEO, Chief Financial Officer or CFO, and Chief Information Officer or CIO. This slide can be found in your textbook on page 254. Clinical Documentation Improvement, or CDI, is the process an organization undertakes that will improve clinical specificity and documentation, allowing coding professionals to assign more precise disease classification codes. CDI improves and supports data quality, availability, and usability, all key aspects of data governance. As stated earlier, existing committees can be used to lay the groundwork for information governance until a formal structure can be created. This groundwork includes many of the activities identified in the Information Governance Charter. A charter is a document that identifies the purpose, scope, and functions of a program. In combination with the work of existing committees, the Information Governance Charter, Plan, and Personnel can be launched. AHIMA has developed an Information Governance Sample Project Plan, shown on page 256 of your textbook, to assist healthcare entities with incorporating information governance into their work. This five-phased process includes a list of activities for each phase of initiation, planning, execution, control, and closeout. SBAR, or Situation Background Assessment Recommendations, is a process for facilitating communication and resolving problems that has been used by many healthcare facilities in their quest to implement information governance. See Table 14.1 on page 259 for descriptions of the SBAR components. An information asset inventory is a list of information resources throughout the healthcare facility. The inventory should be stored in a spreadsheet or other tool to facilitate access to and ongoing maintenance of the list. This inventory should include both paper and electronic records, reports, medical imaging, and both structured and unstructured data. The inventory is critical to the creation of an information governance program because all of the data and information to be managed must be known. Strategic alignment is the process and outcome of linking your organizational structure and resources with your strategy and business environment to achieve performance improvement. AHIMA took an assertive and proactive role in the acceptance and promotion of information governance concepts and has worked with ARMA International, formerly known as the Association of Records Managers and Administrators, and other key healthcare stakeholders to develop information governance best practices. The result of their collaboration was Information Governance Principles for Healthcare, or IGPHC. IGPHC applies to all aspects of information and subsequent business transactions across all areas of the healthcare industry organizations. A stakeholder is someone who has a concern about the identified issues and the healthcare facility's data. AHIMA used the generally accepted record-keeping principles from ARMA International to develop the founding 8 key principles for information governance. The 8 key information governance principles, which are defined in Table 14.2 on page 261 of your textbook, are based on accuracy, timeliness, accessibility, and integrity. They are as follows: 1, accountability; 2, transparency; 3, integrity; 4, protection; 5, compliance; 6, availability; 7, retention; and 8, disposition. Information technology governance, or ITG, is a subdomain of information governance and is essential for any organization using information technology. ITG is the management of all information technology investments, including the selection, implementation, maintenance, evaluation, and its coordination. Information technology governance also encompasses every aspect of information technology infrastructure, such as hardware, software, communication, and technology tools, policies, and procedures to provide efficient processes for all electronic activity within the healthcare facility. Information technology governance is typically led by the Chief Information Officer, or CIO. This slide is a diagram of data governance, information governance, and information technology governance and their relationship. This can also be found on page 262 of your textbook. Enterprise Information Management, or EIM, is the set of functions used to plan, organize, and coordinate people, processes, technology, and content for managing information as a corporate asset that ensures data quality, safety, and ease of use. It is ensuring that the processes are in place to generate trust in the information being used. This slide should say Enterprise Information Management. Enterprise Information Management is a continuous program that facilitates the triple aim of healthcare, which is to improve population health, enhance the patient's experience within the healthcare field, and to reduce the per capita cost of healthcare services. The building blocks of EIM are identified as essential foundation pieces for successful EIM. These building blocks are the following: privacy, security, and confidentiality; integrity and quality; design and capture; content and records management; access and use. AHIMA developed a prototype plan referred to as the Information Governance Adoption Model, or IGAM, to assist healthcare facilities when attempting to implement information governance. The Information Governance Adoption Model competencies are shown on page 265 of your textbook. There are 10 core competencies in the Information Governance Adoption Model. These core competencies have performance measures that a healthcare facility can use to guide them through their implementation. The first is information governance structure, which creates the information governance program, including executive sponsorship, information governance committee, and policies and procedures to support the program. Two, strategic alignment, which ensures that the information governance program strategy aligns with the organization's strategy, mission, vision, and goals. Three, privacy and security, protects information across all types of information, all media throughout the life cycle. Four, legal and regulatory, verifies proper, accurate, reliable, efficient response to regulatory audits, information requests, and e-discovery. Five, data governance, which ensures usable and reliable data through comprehensive and proven data management practices. Six, IT governance, which strives for risk reduction through an integrated approach to technology selection, evaluation, and use. Seven, analytics, which proves the value of information governance and contributes to data-driven decision-making culture in a healthcare facility through the use of advanced tools and technologies. Eight, information governance performance, measures the performance and impact of the information governance program. Nine, enterprise information management, which guides practice for information through the information lifecycle across the healthcare ecosystem. This ensures the value of information assets, requiring an organization-wide perspective of information management functions. It also calls for explicit structures, policies, processes, technology, and controls. Part B to this competency is the infrastructure and processes to ensure the information is trustworthy and actionable. And finally, the 10th core competency is awareness and adherence. This creates a path for trusted information and safe use of health IT through consistent behavior with respect to information use, sharing, handling, access, storage, retention, and disposition. Generally, it takes approximately 12 to 18 months to implement an information governance program, depending on the size of the healthcare facility, personnel involved, budget, and other resources. Collaboration is the key imperative people skill for the information governance leader because employees throughout the healthcare facility must be involved. This collaboration involves bringing various people and departments together, finding common ground and solutions, and coming to a consensus for a plan of action. Regardless of the HIM professional's role in data governance and information governance, two sets of skills are necessary for HIM professionals: hard skills and soft skills. Hard skills deal with the basic areas of technology. These hard skills include basic computer literacy, programming basics and languages, Use of basic office application software, including bases, graphics, and spreadsheets, and decision support systems. Hard skills also include data analytics skills, including healthcare statistics and research fundamentals, trend analysis and predictive modeling, financial data and budget analysis. Data use skills encompass the application of secondary data, data visualization or display techniques, and the ability to use any technology to collect, store, analyze, and report a wide variety of information. Soft skills refer to more subjective traits that involve perception and more analysis. Communication skills not only involve verbal and written forms, but also interpersonal skills, collaboration, and understanding what was meant in addition to what was said. Critical thinking uses logic and reasoning to interpret situations and people, apply principles to processes, and creating new ideas. Decision making and judgment aid the ability to choose the best option based upon some type of cost benefit analysis. Three HIM roles related to information governance and data governance are data steward, clinical data improvement coordinator, and data analyst. Data stewardship is the formalization of accountability and a continuum of stewardship responsibilities across the data lifecycle and across the enterprise. Data stewardship is carried out by a network of designated employees who are responsible for managing, collecting, viewing, storing, sharing, disclosing, and otherwise making use of personal health information. Health data stewardship is the management and responsibilities of an activity according to its established goals and objectives, regulatory and accreditation conditions, and other organizational obligations to guarantee that health information is used appropriately. To prove competence in this realm, an HIM professional or other can become a certified clinical documentation improvement coordinator or practitioner, which is the CDIP certification. This is an HIM credential awarded to individuals who have achieved specialized skills in clinical documentation improvement. The health data analyst uses application skills to manage, analyze, interpret, and transform health data into accurate, consistent, and timely information. HIM professionals can apply their knowledge and skills of data analytics to facilitate the transition to information governance. The Certified Health Data Analyst, or CHDA credential, identifies practitioners who have the knowledge to acquire, manage, analyze, interpret, and transform data into accurate, consistent, and timely information while balancing the healthcare facility's strategic vision with day-to-day details.